Why bamboo foods could be the most important hidden ally in human metabolic health. What if one of the most overlooked food sources on the planet holds a key to improving human metabolic health in ways modern nutrition has barely begun to understand? What if a single category of plant foods could support blood sugar regulation, improve cholesterol levels, promote digestive balance, deliver antioxidant protection, and simultaneously serve as an environmentally sustainable food source for a growing global population? If this sounds almost too good to be true, it is only because scientific research into this remarkable plant has been limited until recently. The plant in question is bamboo, not as a construction material, nor merely as the iconic food of pandas, but as an edible, nutrient-rich food source with potential implications for human health that are only now beginning to emerge. Far from being a novelty or a niche culinary ingredient, bamboo has sustained the diets of countless cultures across Asia for millennia. Traditionally consumed in a wide array of dishes, soups, salads, stir-fries, fermented foods, and more, bamboo shoots, leaves, and even processed bamboo products have played a role in the daily nourishment of communities long before modern science began cataloging their nutrient profiles. In this detailed article, we will explore what bamboo foods are, how they have been used historically, what modern research shows about their effects on key metabolic markers, how they interact with the human gut microbiome, what risks and cautions should be understood, and where the scientific journey into bamboo's metabolic potential is headed. By the end of this exploration, you will have a far deeper appreciation for how bamboo foods function as more than traditional fare, how they represent a promising frontier in nutrition science and metabolic wellness. Bamboo is a member of the grass family, and there are over 1,250 different species of bamboo growing in diverse ecosystems around the world. While bamboo is perhaps most famous as the staple food of giant pandas, its use as a culinary ingredient extends far beyond that iconic association. In many parts of East and Southeast Asia, including China, Japan, Korea, Thailand, and India, bamboo shoots and leaves have been consumed as part of traditional diets for centuries. In rural communities, bamboo shoots are harvested seasonally and incorporated into everyday dishes, valued for their crunch, neutral flavor, and ability to absorb the flavors of other ingredients. Nutritionally, bamboo shoots are low in calories and fat, yet offer a meaningful profile of macronutrients and micronutrients that contribute to human health. They provide a moderate amount of protein for a plant food, substantial dietary fiber, and essential minerals such as potassium, selenium, magnesium, and manganese. The fiber content, in particular, is significant for digestive health, as it promotes regularity and supports the growth of beneficial gut bacteria. Bamboo shoots also contain phytochemicals, plant compounds that may have antioxidant, anti-inflammatory, and metabolic regulatory effects. When considering bamboo as food, it is essential to recognize its dual nature, both as a traditional staple in many cultures and as a source of nutrients that align with modern understandings of metabolic health. Bamboo leaves, although less commonly consumed than shoots, are used to make teas and extracts that are rich in antioxidants and bioactive compounds. In some cultures, fermented bamboo shoots are a specialty, combining the nutritional benefits of bamboo with the metabolic advantages of fermented foods. Scientific interest in bamboo foods has grown gradually, but the body of research examining their specific effects on metabolic health remains relatively limited compared to studies on more mainstream foods. Nonetheless, the studies that have been conducted reveal intriguing patterns and raise important questions worth deeper investigation. Researchers have approached the study of bamboo foods from several angles, including human clinical trials, animal studies, in vitro cellular experiments, and analyses of traditional food processing methods. This diversity of research approaches allows for an increasingly comprehensive understanding of how bamboo components interact with biological systems. One of the most promising areas of research has been the investigation of bamboo's role in regulating blood sugar levels, a central aspect of metabolic health. Several controlled human trials have explored how bamboo-fortified foods influence post-meal glucose responses, insulin sensitivity, and other markers associated with diabetes risk. Although the number of such trials is still small, the results point toward consistent patterns in which bamboo foods appear to support more stable blood sugar profiles compared to control foods without bamboo components. Another critical area of investigation involves the potential lipid-modulating effects of bamboo foods. Studies indicate that certain bamboo extracts and bamboo-enriched diets may contribute to healthier cholesterol profiles, including lower levels of low-density lipoprotein LDL cholesterol, the so-called bad cholesterol associated with cardiovascular risk, and improved overall lipid regulation. One of the most discussed findings in the research on bamboo foods relates to blood sugar regulation. Metabolic diseases such as type 2 diabetes are characterized by dysregulated glucose metabolism, insulin resistance, and chronic elevation of blood glucose, all of which contribute to tissue damage, vascular complications, and systemic inflammation. Dietary strategies that help stabilize blood sugar are therefore central to preventing and managing diabetes and related metabolic disorders. Human studies examining bamboo foods have yielded promising signals. One trial involving participants with diabetes found that consuming bamboo-fortified cookies led to significantly lower post-meal blood glucose levels compared to standard cookies without bamboo. This suggests that the dietary fiber and specific bioactive compounds present in bamboo shoots may slow carbohydrate digestion and glucose absorption in the gut, mechanisms that help reduce spikes in blood sugar after eating. Human studies examining bamboo foods have yielded promising signals. One trial involving participants with diabetes found that consuming bamboo-fortified cookies led to significantly lower post-meal blood glucose levels compared to standard cookies without bamboo. This suggests that the dietary fiber and specific bioactive compounds present in bamboo shoots may slow carbohydrate digestion and glucose absorption in the gut, mechanisms that help reduce spikes in blood sugar after eating. Beyond this clinical trial, additional research in animal models has demonstrated that extracts from bamboo shoots can enhance insulin sensitivity, reduce fasting glucose levels, and improve glucose tolerance tests. These findings, while not yet confirmed in large, long-term human studies, point toward a plausible mechanism in which bamboo's fiber and phytochemicals work together to support more balanced glucose metabolism. In the context of everyday dietary patterns, incorporating bamboo foods as part of carbohydrate-containing meals may help mitigate the glycemic impact of those meals. For individuals predisposed to metabolic dysfunction, this potential moderating effect on blood sugar warrants serious attention. In addition to blood sugar regulation, metabolic health encompasses lipid metabolism, the body's handling of cholesterol, triglycerides, and other fats circulating in the bloodstream. Abnormal lipid profiles, particularly high LDL cholesterol and elevated triglycerides, are well-established risk factors for cardiovascular disease, the leading cause of death globally. Emerging evidence suggests that consuming bamboo foods may have a favorable impact on lipid profiles. Human trials have observed reductions in LDL cholesterol and improvements in total cholesterol levels among participants who consume diets enriched with bamboo shoots. These changes are biologically meaningful, as lower LDL cholesterol reduces the risk of atherosclerosis, the buildup of plaques in arteries that leads to heart attacks and strokes. Mechanistically, the fiber in bamboo shoots likely binds to bile acids in the digestive tract. Bile acids are made from cholesterol, and when fiber binds to them, the body must draw more cholesterol from the blood to produce new bile acids. The result is a net reduction in circulating LDL cholesterol. Additionally, phytosterols, plant compounds found in bamboo, may compete with cholesterol for absorption in the intestine, further contributing to improved lipid profiles. While these findings are encouraging, it is important to note that the magnitude of lipid improvement seen in bamboo food studies is comparable to what might be expected from other high-fiber, nutrient-dense plant foods. What makes bamboo particularly interesting is its combination of fiber, micronutrients, and sustainability as a food source.